Welcome students, Creative Educations created by Mr. Shuklambar Shaw. Hello, good morning students. Today we will discuss about the force and pressure. Now student, you know very beginning what is the force. Force is a pushing and pulling of an object is known as the force. Now students, we know about the pushing. A force to move an object away from our body. And second thing, pulling. A pull is when we apply a force to move an object towards our body. So example of push and pulling. Pulling, drawing a tables and pressing the pedals of cycle is called the pushings. Now students, move to the pressure. So force per unit area of an object is known as the pressures. Now students, you know that a force cannot be seen, but we can feel and observe the effect of the force. Now in other words, we can say a force and perpendicular to the surface is called the thrust. Now students, you know that pressure is the thrust acting per unit area. So you know formula of the pressures. Now pressure is equal to thrust per area. So in numerical we can say P is equal to F by A. Now what is the SI unit of pressure students? Newton per meter square, or we can say that is called the Pascal. What is the CGS unit of pressures? Pressure is dyne per centimeter square. So students, let's know about the 1 pascals. A force of 1 Newton is applied over a body of surface area 1 meter square. Exerted pressure is said to be 1 pascal. Now students, now move to the force is not a pressure. Force determines how much an object will change velocity in unit time, but pressure determines how much that force will feel. Now what are the factors on which the pressure depends? The pressure exerts on an object depends on the force exerted on the object. In fact, the pressure is directly proportional to the force. Second, the pressure depends upon the area over which the force is applied. In fact, the pressure is inversely proportional to the area. So, in force, more pressure when area is constant. But second things, area, more area, less pressures when force is constant. So now let's move to the activity 1. In which case the pain is more? Case 1, a lady is wearing sneakers on Monday. You are sitting on a bench reading newspaper. She starts jogging and accidentally puts her step on your foot. Case B, some lady is wearing heels on Tuesday. You are sitting on a bench waiting for a friend. She was walking. In order to take rest, she moved towards the bench and accidentally steps in your foot. Now students will discuss what is same in both cases. Now the force applied in both cases is same. Second, we will discuss what is different in both cases. Now in case 1, we know that students, force is applied on bigger area, but in case B, the force is applied in small area. Come back to the activity 2. Person poke with finger. Case 1, pressure in the form of a pen due to a force will be less. Person poke with a sharp end of needle. In case B, pressure in the form of a pen will be more. So where the pressure will be more, where the pressure will be less. Now in case 1, where the area will be less, the pressure will be more. Where the area will be more, the pressure will be less. Activity 3, force exerted by weight of a person. Let 600 Newton. Find the pressure. Now positions, let's start with the position, area in contact, then force, then pressure. In a column, in a table, what we can arrange Then find out when a body is standing or when a person is standing, area in contact is 0.05 meter square and force is 600 Newton. What should be the pressure? Pressure is equal to force per area. So pressure is equal to 12,000 Pascal. Now second, the position of the body or man is sitting, where the area in contact is 0.1 meter square. Again, the force is constant 600 Newton. So pressure is equal to 6,000 Pascal. Third things, the body is lying down, where the area in contact is 0.4 meter square and force is equal to 600 Newton. Now pressure is equal to how much, students? That is pressure is equal to 1500 Pascal. So where the pressure will be more? In case of standing, pressure will be more because the area of contact will be more. The area of contact will be less, having same pressure. Third thing, what is the difference between the force and pressures? Student, you know that force is a push or pull of an object. It is a direction. It having direction. It's having a vector quantity. But pressure, ratio between the intensity of force and area on which it acts is known as the pressures. It does not have any directions. So finally what we can say, the same force produces less pressure if it acts on a large area, but can produce more pressures if it acts on a small area. Now everyday observation, what we can find in an examples we can go through in our day-to-day lives. First observations, school bags have white straps, so the weight of the bag may fall over a large area of the soldiers, of the students, producing less pressure. This is the one best examples students should remind. Second examples, a sharp knife cut better than a blunt knife because the pressure of our hand falls over a very small area of an object produces large pressure. Therefore, we can say a sharp knife having cuts better than a blunt knife. Third, we can say in our day-to-day, which can be found in the motor vehicles and mechanics, the tractor have a broad tire because there is the less pressure on the ground and do not sinking to the comparatively soft field. That's why it is used in the field for the cultivation or for the culture purposes. Next, we can say the easier examples very much you can find in our the locality or in our the day-to-day lives. It is easier to walk on soft sand if you have flat shoe rather than shoe with a sharp knives. Third things, you know that students, the foundations of buildings and dams are laid on the larger area to produce less pressures. So these are all the superior examples we can find on the behalf of the force and pressure. Next, finally, the wooden or concrete sleepers are kept below the railway lines. Because of what? Because for the less pressures in the same forces. A wide belt is provided over the wheels of an army tanks because of large area, less pressures. So students, you know all the things. This is all about your the day-to-day lives of force and pressures. Thank you students. Thank you.